Hey guys and girls, welcome to 10.3, the section on applying properties of chords. So today we're going to use properties of congruent arcs. We're going to determine if a chord is a radius, just kidding, a diameter of a circle, and then we're going to use properties of chords and diameters to find missing chords and arcs. Okay, so two minor arcs, meaning they're under 180 degrees, are congruent if and only if, here's how you could tell, they have to be created, they are formed or created by congruent chords. So I know you're saying, what the heck does that mean? Well, if you look at this picture here, this chord and this chord, CB and AB, they're congruent chords. What that means is that they've created two arcs that are also congruent. So if I want to find the measure of arc CA, what I have to do is first find what x is. So the way I'm going to do that is because they're congruent, I could set them equal. So 2x plus 48 is going to equal 3x plus 11. Okay, so now solving for x, we're going to get 48 equals x plus 11. Subtract 11 from both sides, x is equal to 37. But notice now what they want us to find is not either of these arcs, they want us to find CA. So in order to do that, I now have to figure out what the measure of CB and AB is. So if I have x, I'm going to plug it in here, and I would get 2 times 37 plus 48. That gives me a measure of 122 degrees. Now to double check that I got that right, I should plug it into this bottom, the green arc as well. So I would get 3 times 37 plus 11, and I get 122. So now, how does that help me find arc CA? Well, the whole circle, remember, is 360. So the measure of arc CA is going to equal 360 minus what these two add up to. So 122 plus 122 is 244. So I take that away from 360, and I would get 116 degrees. Okay, so here are our next two theorems. The first one says if a diameter is perpendicular to a chord, then it bisects the chord. So let's take a look at this picture on the right. My diameter would be AB. It's perpendicular to the chord FE. What that means then is it splits it. Bisecting means it splits it into two equal pieces, which is why we have these two tick marks there, because they are congruent. Now, the reversal of that says if one chord is the perpendicular bisector of another, then the chord is a diameter. So here, let's say I didn't know AB was the diameter. If I looked and saw, those two things are happening. It's perpendicular to chord FE, and it splits FE into two equal pieces, then I would know right away that AB is a diameter. Okay, so let's use that theorem for this next problem. Here we're going to be given some information. They told me that chord DB is 12 inches, FE is 8 inches. Well, DB is the entire chord right here. It's 12. Notice that AC is perpendicular to it. That makes it a diameter, and if it's perpendicular to it, that means it bisects it. So I can say that BE is equal to 6 and DE is equal to 6. Another piece of information they gave me is that FE is equal to 8, so I'm going to write that right there. They want me to find the length of FB. One of the things that's confusing with these problems is not the segments that you're looking for won't always be drawn in. So just draw it in and label it. It's X. Now, hopefully you guys all see that what I have here is a right triangle. I'm going to rewrite it over here. 6 is one leg, 8 is another leg, and my hypotenuse is X. I'm going to do the Pythagorean theorem. So 6 squared plus 8 squared is equal to X squared. You get 36 plus 64 is equal to X squared. 100 equals X squared. Now when I take the square root of both sides, I do get plus or minus, but because this is the length of a radius, I don't even want the negative value because it wouldn't exist, so my value is X equals 10. Now I'm going to look back and make sure that I solved what they wanted me to find. They wanted me to find FB. I found it. It's 10. All right, so this next example, example 3, is a variation of example 2, except much, much more difficult. Well, okay, not much more, but I do need you to really, really pay attention to this or you're going to get lost. All right, in the figure, dB equals 40, I think it should be millimeters. FE is 8 less than FB, find AE. All right, they only gave me one value here, notice, and they gave me dB. So what I'm going to do is the same thing as last time. I'm going to label this. If the entire chord dB, if this whole thing is 40, then I know that each little piece here is 20. Again, they're asking me for a piece that's not even drawn in the picture, so I'm going to draw in FB. So the only thing they told me about FE and FB is that FE is 8 less than FB. Well, if I knew what FB was, I would just subtract 8 from that and know what FE is, but I don't. So what I have to do is label FB as X, and FE is X minus 8. All right, now I'm going to do the exact same thing as before. I'm going to do the Pythagorean theorem, except now I don't have two numbers. I have X minus 8 squared plus 20 squared equals X squared. Don't forget that when you have a binomial, two terms that are being squared, you have to write it out twice and then FOIL it. So first times first, X. Outer is minus 8X, inner is minus 8X, last times last is plus 64, and then plus 400 equals X squared. Combine like terms here on the left side, sorry it's so messy. X squared minus 16X plus 464 equals X squared. Luckily, and hopefully you see, the X squareds drop out, so you should be happy about that. And you're left with negative 16X plus 464 equals 0. Negative 16X is going to equal negative 464, and then divide by negative 16, X is going to equal 29. All right, so again, now we have to go back and see what we have to find. Our goal was to find AE. All right, so AE is the diameter, not the diameter, I'm sorry, it's the radius. It's this piece plus this piece. Well, X is 29, so I know that this segment right here, if I plug in 29, I'm going to get 21. If X is 29, that's the same value all the way around, so AF is also 29. All right, so the entire length of AE is going to equal 29 plus 21, I would get 50 millimeters. Okay, so that one was a little bit tricky because once you find your value of X, you had to use it twice in order to find the entire radius. All right, last theorem. All right, so what we have here is it says that if two chords are congruent if and only if they are equidistant from the center of the circle. Recall from last semester that equidistant means, okay, so let's see, KG and FH. You can measure the distance various ways. It has to be a very specific one. It has to be along a perpendicular, so that has to be there, and then these segments would have to be congruent. Then you would be able to say that yes, KJ and FE are the same length. So our first example comes here. If CG and CH both equal 4, so let's put that in there. We want to find KJ. All right, in order to find KJ would be this entire segment. I have to find at least that piece, KG, because then that gets split in half, because remember, if a segment is perpendicular to a chord, it bisects it. So GJ is going to equal the same length as KG. In order to do that, if these chords are congruent, then HE is the same length as GJ. Those are the exact same length. So I'm going to use the Pythagorean theorem here on this triangle. 4 squared plus X squared equals 5 squared. So I get 16 plus X squared equals 25. X squared equals 9. X is equal to 3. Okay, it would be plus or minus. We don't take the plus or minus. So now KJ, the segment that they wanted me to find, is 3 plus 3, so it equals 6. Okay, this was a tricky one because you have to think about all the things that are congruent in this picture, and it would be this segment's congruent to this segment, which is congruent to this segment, which is congruent to that segment. Okay, last example that I'm going to do with you guys is example 5. In the figure below, CG is equal to CH. If KJ equals 7, find the measure of angle HCE. Use this to find the measure of arc FE. All right, so there's quite a few things going on here. First of all, let's mark what's congruent in the picture. CH is congruent to CG. And then because those are congruent, that makes chord FE congruent to KJ. Because those two chords are congruent and bisected by a perpendicular, this becomes congruent to this, which is congruent to this, which is congruent to that. So a lot of congruencies here. All right, KJ is equal to 7. And our goal, we want to find the measure of angle HCE. Let me see if I could zoom in here a little bit so I could just, whoa, okay. So we want to find, sorry it's crooked, but we want to find this angle here. Now, in my picture, I have a triangle, right? I have this triangle here, CHE, and I only have one side of it. I only have that hypotenuse, it's 5. So I have to use some of the facts from that I learned today. If KJ is 7, that means FE is also 7. And then it gets bisected, so this side is 3.5. Okay? Now, we have to use a little bit of trig in order to get, I'm trying to switch colors here. I want to do trig on this triangle. So I have, here's my right angle, here's x, the hypotenuse is 5, and this leg is 3.5. Let's label our sides with respect to the angle. I have the opposite, 3.5 would be the opposite, and I have the hypotenuse. So I'm looking for x. Opposite and hypotenuse is sine, so sine of x is going to equal 3.5 over 5. Try to remember from chapter 7, if you're solving for angles, you have to use inverses. So sine inverse of 3.5 over 5. Let's take our calculators, and we should get the answer of 44.43. If you notice, though, what we were supposed to do is find the measure of this arc from F to E. So what I have to do is find the angle that creates that arc. So here I could draw this triangle. These triangles are similar, so if this angle is 44.43, then this angle is also 44.43. So the measure of angle FCE is 44.43 plus 44.43, which is 88.86. Keep in mind from yesterday's section that the central angle is the same as the measure, the central angle and the arc that it intercepts have the same measure, so the measure of arc FE is 88.86 degrees. Okay, I think I said that that last one I was going to do was going to be the last example. I lied. Let's do a couple more together. All right, we want to find the measure of arc AC. Well, we don't know what it is, so let's call it x. Now, if arc AC is x, arc CB is also x because they were created, those two arcs were created by congruent chords. So I know that the sum of these three angles, 116 plus x, because they form a circle, is 360. So 2x plus 116 equals 360. 2x is going to equal 244. And x is equal to 122. So therefore, the measure of arc AC is 122 degrees. Okay, so this next example, example 7, we have to think about a couple of things that we've learned in this section. So I notice here that I have two little chords, JK and ML. And I notice that they have the same length. They're both 12. Then I see these chords, 7x minus 10, and then I have 3x plus 6, and they're both perpendicular to those chords. So we learned earlier that if a diameter is perpendicular to a chord, it bisects it, and then we also learned that those chords are going to be equidistant. If these JK is congruent to ML, then this piece becomes congruent to this piece. So I just am going to set 7x minus 10 equal to 3x plus 6. I'm going to solve for x. I get 4x minus 10 equals 6. 4x is going to equal 16, and x is equal to 4. And my explanation for this would be that if I have congruent chords that are, bisected perpendicular, then they are equidistant from the center of the circle. Okay, so that's my explanation for why that's true. All right, last two problems of this section, we are going to determine if PR is the diameter of the circle shown and explain. Remember, two things have to happen in order for you to know that it's a diameter. First of all, the segment has to get bisected, which it does right here. It's 8 and 8. But the thing that we don't know, are those two chords perpendicular? There's no indication that they are perpendicular, so we know it's a bisector. We don't know that it's perpendicular, so PR is not necessarily a diameter. Okay, this last one I want you to try on your own. You're determining whether PR is a diameter. If you don't remember what has to happen in order for you to know that that's a diameter, please look back to the theorem earlier in this section to see if it is or not. All right, that's it. I know there's a lot of information in this section. It was kind of confusing, so we'll go over a lot of things tomorrow in class if you have any questions. All right, thank you for watching, and I hope you have a fantastic day. Bye.